Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. On. In this tutorial video, I'll go through this June 2015 paper 1.3. So this is a A-level Cambridge International 9701, but the contents within are perfectly suitable for any 16 to 18 years old students studying chemistry. In this first question, we have a Boltzmann energy distribution curve. We know it's the energy on the x-axis and the number of molecules on the y-axis, and we have these two activation energy. EA1 is lower than EA2, so that the area under the graph here represents the amount of molecules having energy greater than or equal to EA2. But EA1 is new and a lower activation energy, so that we have an additional blue color region plus the red color region. There is the total area under the graph now with energy greater than or equal to this new lower EA1. So which statement about EA1 is correct? Well, it is a new lower activation energy, and that can only happen if you have an alternative reaction pathway as a result of the use of a catalyst. And this one will be from a catalyzed reaction. So EA1 is a new lower activation energy from a catalyzed reaction, which means uncatalyzed is going to be wrong. So we're left with between A and C. We have these use of words fewer and greater. Fewer there must mean lesser as compared to greater. In terms of collisions, if we have a new lower activation energy, as I mentioned, the area under the graph there with energy greater than or equal to EA1 will be bigger because it includes the blue and the red color region, which is just greater than just the red color region on its own. So we get a greater number of effective collisions, and therefore our rate will be much faster there. Question 2, we're looking at an ideal gas. We have a PV graph against N. We know that PV equal to nRT. So if we have PV against N, this is equal to RT. And if temperature is constant, according to the questions, constant temperature here. So this must be equal to constant. But we also know that PV equal to constant. So PV equal to constant, and let me think, is that true? So if RT is constant, that means when N increases, PV must also increase, because if bottom gets bigger, the top must get bigger, otherwise this value will change, and you don't want the gas constant to change, you don't want temperature to change. As N increase, PV must increase because you get a greater number of particles. You get greater number of particles, and they can occupy greater volume and they can exert greater pressure. So it is not constant per se, like PV equal to constant in those cases, because here the number of molecules are changing, and these have to remain constant by this relationship. As this bottom increase, this top has to increase as well. Question number 3. So we have been asked to measure the enthalpy change of combustion for ethane. So this student used these following values. These are combustion of carbon, and this is combustion of hydrogen. If you write an equation, there's C plus O2 giving you CO2. Stat symbols are very important in this topic. So we have to balance equation as well as the correct stat symbol. We have to burn only 1 mole of the substance in excess oxygen. Everything in their standard state under standard conditions, so this must be half O2 like that. Now, this student calculated the enthalpy change of formation of ethane to be minus 140 kJ per mole. What do you want? You want the student experimental value for the enthalpy change of combustion of ethane. If I write an equation for this, I will have, let me think. So if we want combustion and we have 2 combustions, do I want to write a combustion equation or do I want to write a formation equation? Seems like a lot of my data is combustion, so perhaps I write formation equation. So if I'm forming ethane, so C2H6, there's 2 carbon solid plus 3 H2 gas, giving me ethane, which is a gas. And this is the formation of ethane, so there's minus 140 kJ per mole. I can be thinking about combustion, CO2 and H2O, so 2 there and 3 there, so gas and liquid. And then I can think about my hash cycle, carbon combusting to give you CO2. So there's 2 times minus 394 because I'm combusting 2 mole of that carbon. And then I'm burning 3 moles of hydrogen, so 3 times minus 2 at 6. Last but not least, I'm burning 1 mole of the ethane. So this is the combustion of the C2H6, which is what I want to find. In terms of the Hess law, it says that enthalpy change of a reaction is independent of which path you take, as long as you start from the same reactant and are the same product. So what we get is delta HF, which is equal to minus 140. The direct path here is equal to 2 times minus 394 plus 3 times, hang on, let me just write that properly, minus 394 plus 3 times minus 286, and then we are going the opposite way, so we have to do minus the combustion of that C2H6. This is a minus combustion of C2H6, so move that to the other side. So combustion of C2H6 is equal to all that thing in the bracket, so 2 times 394 negative, plus 3 times 286 negative, minus 1646. I move this to this side, minus 140 move to the other side, I get plus 140. And I will get minus 1506 kilojoule per mole. So that is just going to be option B there. Question number 4, which one have species with different shapes, shape of molecule? Beryllium dichloride is actually covalent, so they have 2 outer shell electrons with group 2 valence electrons, so 2 single covalent bond there, and this is CO2, so both of them are linear, and these are 180 degree, they don't have different shape. CH4 tetrahedral, obviously 4 bond pair and 0 lone pair. The 4 bond pair repel equally. There's the same thing when you form an ammonium ion, that is the dative covalent bond in the AS bonding syllabus. So ammonium ion is also 4 bond pair because the dative covalent bond count as 1 bond pair, 1 sigma bond as well. So they are both tetrahedral, 109.5 degree there. NH3 has a lone pair, BF3 has no lone pair, BF3 is trigonal planar, 120 degree. NH3 on the other hand is going to be pyramidal with 1 lone pair because it's got 3 bond pair and 1 lone pair there. 107 degree versus 120 degree, different shape, different bond angles there. SCl2, so chlorine forms single covalent bond, so that looks just like water, which is also bent 104.5 degree with 2 bond pair and 2 lone pair there. They look pretty much similar, except the chlorine will have 7 outer shell electrons, so therefore you use 1 for bonding, you still have 3 more lone pairs or 6 outer shell electrons, but hydrogen doesn't have that, but the shape is going to be similar and the bond angle is going to be similar. Question number 5, in which reaction does the element have the largest change? Not the largest oxidation number, but the largest change. Cr2O72 minus, this is your orange color dichromate 6 acidified. This is chromium plus 6. If you think about minus 2 overall charge to chromium, 7 oxygen, 7 times minus 2 there, to chromium, minus 2 plus 14, chromium plus 12 over 2 plus 6. And then this is chromium plus 3. Oxidation number of ion follows the charge on the ion. The ion there is plus 3. The ion there is plus 2. So the change there is plus 6 to plus 3 is minus 3. Plus 2 to plus 3 is plus 1. We have to check for the rest of them. This is chloride, so it's chlorine minus 1. ClO3 minus case study. This is chlorine plus 5. If you want, you can have a look at minus 1 overall charge of the ion. And then 1 chlorine and then 3 oxygens. So each chlorine there is minus 1 plus 6. This is plus 5 in ClO3 minus. This is a case study in AS group 7 disproportionation case study, chlorate bracket V, chlorine in plus 5 oxidation number. Or Cl minus, so that is minus 1 equal to chlorine plus 1 times minus 2. Minus 1 overall charge of the ions, minus 1 is the oxidation state of the ions. So you get chlorine of plus 1. This is in ClO minus. This is called chlorate 1. So what you have there is chlorine plus 1 going to chlorine plus 5 and chlorine minus 1. Well, we have to check for the rest of them, so better get going. So iron plus 2, MnO4 minus is manganese plus 7. I'll leave you as an exercise for you to do on your own. That is manganese plus 2. Last but not least, we also have this lead compound. So this is a compound with no charge. Each oxygen is minus 2. There's lead plus 4. tin plus 2. Now tin go to plus 4 and lead go to plus 2. In terms of the element, in terms of the biggest change in oxidation number, plus 7 going to plus 2 is minus 5. Seems like here, plus 4 to plus 2, plus 2 to plus 4 is just change of 2. This is change of 5. This is change of 4. This is change of 3. So the largest change in oxidation number has to be the plus 7 going to plus 2. There's a change of minus 5 there, decrease of minus 5. Question number 6, you want to think about intermolecular hydrogen bonding. You must have hydrogen bonded to oxygen, fluorine, or nitrogen, very, very polar bond, and then they must have lone pair on the nitrogen, oxygen, or fluorine. Ethanol definitely can form hydrogen bond if you have CH3, CH2, OH like this. So the rest of the molecules are not that important, but what is important is between the alcohol, you will have this OH, and this is delta plus, this is delta minus. So from the lone pair on the electronegative atoms, it will form hydrogen bond to the neighboring molecules of itself, and then it has the delta plus attract delta minus, the delta minus attract delta plus, and it must have lone pair on the electronegative atom there. A is definitely the correct answer. Propane is a gas. It only have weak, very, very weak van der Waals, which is also known as induced dipoles, but I think the new syllabus have introduced the term called London dispersion. They all pretty much mean the same thing. You will get away with van der Waals regardless. HCl has no hydrogen bonds, only permanent dipole, so it is polar due to the difference in electronegativity, but then this is plus van der Waals as well, so no H bond there because you don't have the hydrogen bonded to electronegative fluorine, oxygen, or nitrogen. Same thing with HI, and same thing with propanone. What you have in propanone is 3 carbon ketone like that. So this is only polar, but no hydrogen bond there because you have oxygen, but you don't have the hydrogen bonded to the oxygen there. Question 7, we are asked to find enthalpy change of reaction. You are given combustion. So this is what you are given. If you are given combustion data, you can go straight to the formula. If you think about reactants going to products, so combustion data means you will get combustion products. So the reactants will burn completely, and this will give combustion of reactant, and then this will give you the combustion of product. And therefore, when we think about our Hess cycle says, Hess law says, enthalpy change of a reaction does not depend on which path you take. So when I come down, I'm going the same direction. When I go up, I'm going the opposite direction. So that is going to be the sum of the combustion of the reactants. So always remember the terminology, because the terminology, the combustion is important. So the direction follows the Hess law, going this way and going opposite way. So minus the combustion of products there. So what do we have on the reactants? We are burning 1 mole of CO. So that is 1 times minus 2 at 3.0. We are burning 1 mole of ethanol. So minus 1 times 7260 minus, use bracket very carefully, 1 mole of that ethanoic acid. So this is just using the formula method, and it will save you a lot of time. But regardless, you must try and do the bookkeeping correctly, because the moment you key in your wrong stuff on your calculator, that is when you will make a mistake. That is why always write them out and use bracket. Now I have got the previous answer. Minus will give me a plus, so be very careful there. So I get minus 134.9, sign, value, and also unit, typical of enthalpy change, sign, value, and unit. This is what you would do in theory paper. This is what you would do in a multiple choice as well, as part of good habit. Question 8, we have, what do we have here? What is the relationship between concentration against time? Concentrations against time. First of all, CH3OH is a product. So if it is a product, the concentration will increase. It does increase, all right? And what else can I say? D is obviously not right because not reversible. How can you get more product and then less product unless it is reversible, unless you go backward, but it doesn't go backward, it's not reversible. So this one is not reversible. What else can I say? we are not doing physics where suddenly there's a sudden change. So it doesn't work quite that way in chemistry. So you don't get that sudden change where the reaction stops. You know, when the concentration of the product become constant, that's when you know reaction stop. It doesn't just stop all of a sudden. Okay, so C is not correct. Now between A and B, what we can say is, which one is going to be correct? What information is there? Well, we can tell that, you know, here your rate is going to be like that. There's an initial rate because this is the tangent. This is at time equal to 0. I drew a tangent and then I draw another tangent at this time here. So this is another tangent, and then I draw a final tangent in green here. So you will see what happened there is initially it is slow, and then red color, it becomes very fast because the gradient becomes very steep, and then suddenly when it goes to green, it becomes slow again. So this is a hallmark. The way this graph looks like, this is the hallmark of something called autocatalysis, where you are producing a product and the product can speed up the reaction, so the reaction goes very fast and you suddenly produce the product a lot more, and then it will slow down again as the reactant gets used up. None of them have transition metals, so none of them are actually products that can catalyze the reactions. So we're just looking at a typical reactions where you get more products over time until the reaction stops. Then it slowly and gradually comes to a halt and become constant, not a sudden change. A is the best answer there. Question 9 is about electrolysis. So electrolysis have long been taken out since no more in the syllabus since 2016. Since 2016, there was a big revamp of the previous syllabus. This is a 2015 paper. So when you do all the papers, you need to keep in mind what is your current syllabus. So I'm just gonna skip. Now maybe I'll just mention about it, but you know, it is no longer in the syllabus. It also not in the 2022 syllabus. So not in 2022 syllabus, not in the 2016, not in the 2022 syllabus as well, yeah? So when you do concentrated aqueous sodium chloride electrolysis, this could be an A2 question actually. So you get Na plus or Cl minus from the salt, and you get H plus and OH minus from the aqueous solution. You're going to discharge the Cl minus as a result of the concentrated or the saturated solution. What's going to happen is this is going to give you chlorine at the anode, and it is going to give you hydrogen at the cathode, and what you will be left behind is this NaOH. So the solutions will become more alkaline. The fact that you have an alkaline solution and you have OH minus and you have Cl2, this is your current syllabus, group 17, disproportionation. So they are going to react and they will give you disproportionation reactions. So you don't want the NaOH to react with Cl2. Therefore, you must have this partition called diaphragm in order to separate these two from mixing together and reacting. Disproportionation, this is in the current syllabus. But the electrolysis is not in your current syllabus. Just be aware there. Question 10. Again, it says here, the use of data booklet is relevant. The current 2022 syllabus says that the data booklet will be given in the actual question paper itself, including the periodic table. You want to find the identity of the metal, and we have group 2, and we have group 1 and group 1. So what I could do is I could assume that they are group 2 first of all. So M2 plus and O2 minus, so MO, and this will be the oxide. So M is the metal, plus oxygen, so M plus half O2 give me MO. This is the molar volume of the gas. This is 24.0 dm cube per mole. So I have 1.00 gram of the metallic element. So the mole of the oxygen is to the metal. So this is normally how I do my mole calculation. You can do whatever you want as long as you get to the correct answer. No one cares. So this is just the mole ratio. 1 mole of metal is to half mole of the oxygen. On the far right, you have 1.00 gram of the metal, which you don't know what is the identity of the metal. So it's 1 over the AR divided by 300 over 24,000. Because this is in cm cube, this is in dm cube. So, you know, I convert it to cm cube per mole by multiplying by 1,000. So you just need to rearrange your equation. So move that up 1 divided by a half is going to be 1 times 2 over 1. So you get 2 over 1 times 300 over 24,000. That is mathematics. And of course, if I want AR, then I get 1.00 times 24,000 over 300 times 1 over 2. And I get 40, so AR of 40 if it is a group 2 metal. Group 2 metal, because my equation, this equation, was for group 2 metal M, and that was how I get the correct stoichiometry in this ratio. Group 2 metal, if we look at the periodic table, the AR of calcium is 40.1. The AR of magnesium, I think it's 24.3 if I'm not mistaken. Let me just quickly have a look. Yep, it is indeed 24.3 in your syllabus, in your data booklet. So, 40.1 is definitely matching this group 2 metal identity for the relative atomic mass. I don't need to check for the group 1 after all. Question 11, this is about gas laws, ideal gas equations. So in the data booklet, you have R equal to 8.31 joule per Kelvin per mole. This is a molar gas constant, energy required to raise the temperature for 1 mole of any gas by 1 Kelvin. What is tricky here is this is in kilopascal. So if I first of all, I do PV equal to M over MR RT, as this is the mole mass over MR. In terms of that, I need to find the MR in order to identify the gas. So instead of rearranging and putting stuff in, I'm just going to put in the mass, 0.65 gram. That is the information given in the question. I have R, which is 8.31 joule per Kelvin per mole. So that is also information that we have from the data booklet. Temperature is already in Kelvin, so that is all good. Pressure is in kilopascal, that is not good. You need to convert to Pascal. Last but not least, the volume is in cm cube. This is the number one thing that a lot of students don't get. This is cm cube, therefore you have to convert to meter cube for you to work in the SI unit. So to get the correct conversion, I normally think about this from basic primary school mathematics. 1 cm is 1 divided by 100 meter. So 1 cm equal to 10 to the power minus 2 meter. So if that is true, I can cube both sides because you want to get cube, right? So whatever you do on the left, you do on the right. So 1 cm cube equal to 10 to the power minus 6 meter cube. So that's going to be my conversion factor, 400 times 10 to the minus 6 meter cube. I've got all my things lined up there. There's not much point of me, keying in again and wasting time. So I'll just key in my calculator straight away since I already got everything laid out properly. That is the same as keying in the equation itself. So stop wasting time. MR of 40.1. So go straight to the data booklet. Have a look at these gases, noble gases. 40.1. The closest is 39.9 argon, so it has to be argon there. Question 12, which one will produce the solution with the highest pH? Highest pH, well, let's think about each and every one of these. Al2O3 is insoluble in water. It doesn't dissolve in water. This amphoteric oxide is just going to give you pH 7. So maybe, we'll think about it. CO2 is weakly acidic oxide. Okay, so this one is going to be below 7. Na2O is going to be basic. When you react with water, you get NaOH. So 2 of that to balance your equation. This is strongly alkaline. Strong base is around pH 13. I'm pretty sure C is the correct answer. SO2 on the other hand, SO2 is sulfur plus 4. When you react SO2 with water, make sure you know how to write the equation. You get H2SO3, H plus 2 of them, SO3 2 minus 1 of them. Minus 2 equal to sulfur plus 3 times minus 2. Oxidation number straight from the AS redox topic, which you must be able to do easily. So that's sulfur, that is plus 4. Because it started from plus 4, dissolving in water is not redox. You get sulfur plus 4 chemistry. That is actually going to be strong acid. So that is pH around 2 or 3. Question 13, barium is more reactive than aluminium. This is about extraction of metal. Again, this is out of 2016 syllabus, and we are now in 2022. It's also out from the 2022 syllabus because to do electrolysis. Yeah, so in terms of your reactivity series, you know, potassium, sodium, blah blah blah, and then you have aluminium, blah blah blah, hydrogen, copper. So the most reactive metal is your potassium in your reactivity series from your 14 to 16 years old O-level GCSE level chemistry. So these are talking about the more reactive metal. If barium is a more reactive metal than aluminium, so barium is above aluminium. So aluminium you have to get by electrolysis. So because carbon, so aluminium and then carbon is below aluminium, so you can't use carbon to reduce that. If you can't do that with aluminium, you can't use carbon to get barium as well. So reducing with carbon will not work. How about electrolysis? Electrolysis could work because you could get electrolysis of aluminium oxide and get aluminium. You could get molten barium chloride and you could get the barium. Aqueous will not work because you have H plus versus Ba2 plus. The H plus will prefer reductions. At the cathode, you will get hydrogen gas instead, so A is definitely out. Reducing barium oxide with aluminium. The more reactive metal you are, you like to lose electron. If you like to lose electrons, you like to be oxidized. If you like to be oxidized, you are stronger reducing agent. Stronger reducing agent. So you know, that means aluminium is a weaker reducing agent than barium. How can aluminium reduce Ba2 plus to barium? So B is the only correct answer there. Not to worry about too much because it's out of the 2022 syllabus. In fact, it's been out since 2016 then.